Hello everyone, welcome to Lecture 10, Groups. I'm your instructor, Ms. Laura Low. In Lecture 10, the first part, we will introduce a prediction example. Then we'll analyze our prediction accuracy. In the second half, we will talk about grouping and introduce list. The first thing, let's talk about prediction. For the data science course, this course, the first thing we introduce you a lot of data sets, and we applied the calculation in Python programming to see the statistic result, and also we show you how to do many tables function to manipulate your column. And finally, we need to do the prediction. So we will talk more about prediction in the future lecture. But now, according to what we already learned, we just want you to do a small demo to show you what is prediction. Let's see the example. So in this week, we will introduce you another text file. So this one, we have a family heights.csv file. So you can see this table. We have about almost 950 rows, the data. So in this table, what you can see is we have many families. We get the height for all the members. We have the father's height, the height of mom, and the height of children. The child is the height for the child. So the children column means total how many children in that family, and also their order and the sex. So even here we talk about child. The child here we all mean the adult child. So we want to see the height actually the child already grew up, so we don't have some bias. So now after you have this table, what we can do? Yeah, of course we can see you have taller parents. The children are taller. But one thing is, for this table, we want to analyze the data set. So eventually we want to have some prediction is, if we know the height for the parents, can we kind of predict what is the height for the children? Yeah, this is what we want to do. Okay, so think about how should we start. The first thing, let's simplify our question. Even we say the parent height will affect children's height since we have father and the mother. How about for now we just have the average for the parent's height first? So we just consider the parent's average height. So we got the average height from the parent. So you know we got the columns for the father plus the column for the mom. Then we divide by 2. So let's simplify this question first. Of course, later on, then you can do your own research more. Maybe you just want to focus on the father's height or the mother's height. But now let's just have one average height for the parent. So then after that, let's add this parent average height. So we create another table we just call height. So we have 3 columns. The first column is the average we just got from the parents. So then we have the child column. We have the sex column. Okay, so then we see the new height table. Sorry, yeah, I forgot to run. Make sure we run everything first. Okay. So here, yeah, we have the average parent's height and the children's height. And so then what should we do? So let's see the data distribution first. So we have the parents' height and children's height. That's 2 numerical data. So definitely let's create a scatter plot. Okay, so let's spend some time to see the scatter plot. Yeah, that's a lot of data, right? So actually we have a lot in the middle. Okay, so that's kind of very difficult to analyze. But then we have some data on the left bottom and some data, I think most data on the right top. So this one is earlier in last last lecture we talked about the weather, right? So the height for hotter day will have the higher lower days. When we say they will have like accordingly, they have the change for the positive change for both numerical data. So you will see the smaller data, smaller parents' height will have smaller child. So that one, they will be on the left bottom because that is a smaller number. So if they have the higher parents, the parents are taller, then the children will be taller. So that's why here we have more data on the right top. So that's kind of one observation we can see. So actually, what should we do? So how about actually another question? Okay, we kind of know they kind of have taller parents, have taller children, but then we still need to analyze that, right? So now here, I just want you to show you another point. Maybe we just narrow down our question. So for example, I just want you to predict the children's height if the parent's height is around 68 inch. Also, here is another format for the comments in Python. You can do like this. Okay. So how to do that? So I want to show you, according to your scatter plot, we can add more information on the scatter plot. Since we say the average height for the parent is 68, right? So we want to get 1 inch range around the 68. So that means it's 67 to 65. So since the height is from 50 to 85, so then we just create 2 vertical lines. So we add 2 vertical lines in the scatter plot. So we just focus on here, okay? So on the other hand, if I want to ask you, if the parent's average height is 68, what the children's height will be? So on the other hand, you have so many different range distribution, right? So kind of, they are not too big range. So I think average will be a good data to represent those dots from here. So then, right, let's find the average from the parents. So we say it's around 68. So that gives them the 1 inch range. So we find the parents' height information from 67 to 68. Then we applied the average function from NumPy. So then we get the children's. So this one actually only for the parents' range is between 67.5, 68.5. Then we get the average from the children. So that we got the mean for the children. Yeah, that will be 67. Okay, so again, that's make the 67 in your scatter plot. So we add 1 more dot. Okay, so that's the mean for the children for the y. So x-axis is 68. So we see the plot again. Okay, so the scatter plots like this, right? So kind of like this dot represent if the parents' average height is 68. So the children's height is about here. It's kind of, so far makes sense, right? How we do. We just try to narrow down the question. So we see the data again. We review the data again. So then, of course, we will add more information in there. But we need to narrow down the question and get to know our data set more. So from what we say about the range for the parents' height is 68. On the other hand, we can apply to all the heights for the parents, right? So we can find the average when the parents' height is 67, find the average for the children. So then that will be a good prediction for us. So on the other hand, here we want to write a function represent what we are doing earlier. We got the range for the parents. So then we have we got the range for the parents. So then we find the mean for the children. And this one actually is our kind of the predict result for the children. So that's why that's write a function for that. Okay, so this function actually predict. So let me write the comment here. Return the average predict. This will be our predict result. Return the average trial height according to the input of age, parent height. Right? Okay, so that's earlier we need to get the nearby. Actually, this one is the column for according to the height. If you want to change it here, because parent height will be more meaningful for you, we can do that too. So we say parent height. Okay, so what we need to do is we just using the parent height to replace the age. Okay, so we got the range for the column for those information about the children's height. So then we return the average. So then you got the function. Okay, so like here we see again, we enter the parent's average height 68. Yeah, that's our result. Okay, so then if parent's height is 70, or actually the children's height is not really close, that close to 70 becomes 68. Okay, so then if 73 like this. So after you have this function, you have all the prediction, right? So right, then we can make this one. We can enter the input value for the parents one by one. But also last week on lecture 9, we learned the apply function from the tables, right? So we can pass this prediction function by passing parents average column. So then you will get the predict height. This one, of course, since you have the columns, so these you call the table. Yeah, I just want to display the result for you. Okay, so we have the predict height actually call the table apply function, passing the predict function and the parents column. So that's why you get another array. So that's all the prediction for the children's height. So that's add this one to the height function, height table. We add this one in the height table. So we call that prediction. So that prediction will be the children's height for all the parents' height. Yeah, if you want to display the table again, you need to show the table. But here, that's just make our scatter plot. Yeah, I think still let me show you the new table. Okay, so you can see the table now. We have parents' average, child, sex, and the height. So that's prediction. So earlier we have scatter plots using the original children's height and the parents' height. So now we want to the same thing, see on the same scatter plot how the prediction distribution. So that's why here, if we want to have the scatter plot, you have one column associated with one more column. So then we just make the scatter plot like this. You select the three, here we have three columns we want to see their relationship. We want to see the scatter plot for the parents' average and children, and the parents' average with prediction. So then when you do the scatter plot, you just need to enter the one associated with all other columns. So that's why here you will see the blue dot is the original scatter plot. Our prediction is like here in the yellow. Yeah, so pause the video to see what you observed. Yeah, if you can see, actually they are kind of the yellow follow a straight line. So that's actually is kind of fit what we say. The taller parents have taller children, right? So actually not too bad. So the next video we will see